So hey guys, welcome back to my channel. Hope you are doing extremely well. And this is your very own mascot at the side. So today's POTD says, is it a tree? Okay, the problem name is it a tree? So let's see what does the problem say. The problem says that we have been given an undirected graph, okay, of n nodes and m edges. Return one if the graph is a tree, else return zero. All right. Now, if you read the explanation of each problem, so here it is in every node is reachable and the graph has no loops, so it is a tree. And it is said 3 is not connected to any node and there is a loop 0, 1, 2, 0, so it is not a tree. So as I read the given examples, I am able to get an hand that a graph is a tree if the first condition for it is it should be connected. What does connected mean? In terms of connected, I want to say that one connected to 2. Okay, now 3. If this is my total graph, then it is unconnected because I can see two portions. Two different portions do not have a edge between them. Now, if I insert the edge here, then it will become connected. Okay, and the second condition is it should not contain a loop. Okay, what does it mean? So if 3 has an edge from 3 to 1, then you can see that a cycle is forming. So a loop means cycle. Okay. So as mentioned here, we just have to check for two things and determine if it is if it is a tree or not. What are the two things? First, you have to check for the connected component, and second, we have to check for the cycle. Okay. If it is present, then no. If it is not present, then yes. If it is a connected component, then yes. Otherwise, no. Okay. So I hope we are clear on the question part that how we have to tackle it. Now let's move individually. We are going to handle connected and cycle components individually. So let's try it for connected first. So suppose you have a graph one, 2, 3, 4, 5. Okay. Suppose these are your edges. Okay, and this is a another solo part. So you can see there are two components here, two individual components. If I can see that one is this graph and one is this graph, like I can break them into two because there is no edges. So two components. So my mind says that if I do a traverse technique, either BFS or DFS, no matter. If I start BFS from here, let's say from here, then from the BFS, I can visit this node, this node, this node, this node. But for this node, I will have to traverse again. So my technique will be if I have to traverse more than one time, then the graph is not connected. Okay, okay. So this will be my technique. I'm trying to don't beat around the bush and come to the straight point. So how will I do that? Simple. I think most of you have been known that what is a BFS or a DFS. So I will be implementing using, I will name the traversal and you can figure out on your own. That is, suppose my components is currently 0. Then I have visited area as common. Okay. And I have a graph. Okay. So for n I equals to 0, I less than n, that is number of vertices given in the graph, I plus plus. So as usual, if vis of I, that is, this is not visited, then traverse from I and components plus plus. After the loop is ended, if my components is greater than 1, that is the graph was not connected, return false. Okay. Else you cannot come to the result right now because you will have to check for cycle also. Okay. So next problem is else detect if present, detect if a cycle is present. Okay. So now coming on to detecting a cycle. So it will be detecting a cycle in an undirected graph. Okay. So like yesterday, it is a two-part problem. We have to do it. Solve two individual problems to solve this problem. So how we have to detect a cycle? Okay. So let us take an example of a graph like 1, 2, 3, 4, 5, and here it is. So you can see this part is a cycle. Okay. So let's see what I can do. Let me draw the adjacency list of the each node. So one's adjacency node will contain two, twos will contain one and three, threes will contain two, four, and five because it is an undirected graph. Fours will contain three and five, and five will contain three and four. All right. So I will simply do a traversal. Let's move by BFS traversal because that will be comparatively easy. Okay. So my Wiz array will look like something like this. My visited array look something like for one, for two, for three, for four, and for five. All of them are zero currently. Okay. So I will see one. So I come to this node. I see that it is not visited. This is my visited array. Okay. I say it is not visited. So I mark it as visited and start my traversal. Okay. Start my traversal. I see that it is connected to two. Okay. So I go to two, mark it as one. Okay. And then I will see the addresses list of two. So now two says it contains one, but one is already visited. But does two and one form a cycle? No. So we have to give an account of the parent, that where did we reach, where from we reach this node. Okay, so we will give account of parent, that is if uh, visited, if node is already visited, in that case, if it is not a parent, then only cycle is considered. Then cycle is considered. As in this case, that discard one because it is not a cycle, comes to three, mark three as visited, explore three. Now you see two is already visited, but 2 is your parent because 3 has come from 2, so discarded. Now it goes to 4 first. So it goes to 4, mark 4 as visited, and then it goes to 5 because we are using BFS, and then it goes to 5. So 5 is also visited now. Okay. So we first explore 4, and then we will have to explore 5. So exploring 4, I see I use 3 to reach to 4, and 5 is another one. So if I go to 5, I see 5 is already visited, but 5 is not my parent. This was the flow, right? So 4 was coming from 3. This was the flow. Now I see that 5 has already been visited, but my parent, 4's parent was 3. So I can say that if it is already visited and the flow is has not come from that direction, in that case, a cycle is detected. Okay. So what is my pseudocode for this one? A pseudocode for this one will be so my Viz array will be initially 0, all set to 0, right? Okay. Then uh, I will make a queue. Okay. Then queue dot push the starting node. Let us say it as 0. Okay. Then sorry, while my queue is not empty, then what you have to do, and you will have to push a pair of type. That 0 is coming from -1 because it is starting. Okay. So my node is queue dot front dot first. Okay. My node is 0 in this case, and my parent is queue dot front dot second. After that, queue dot pop. Okay. So now explore the edges connected to node. For auto it in adjacency list of node, If it is already visited, then there can be two cases. What are the two cases? If it is equals to parent, then continue, no problem. Else, return false. Because if it is not parent, then there is a cycle for sure. So return false. Okay. But if it is not visited, then there is a case that you have to just push your node, push it. Now parent will become my node. Okay, because node is transferring me from itself to the it. Okay, and viz of it equals to one. Since that is simple BFS. Okay, if this statement is not executed either here or in the upwards, then in that case, return true. Okay. So for summary, I will tell you what I've done. Firstly, I checked if it is a connected component, and secondly, if I check if it contains a cycle or not. Okay. So this was my whole approach. So let us code it down real fast. I hope it was very clear to you. I don't think it is a tough problem, but it can come in an interview. It is a two-way problem, so interview can check both the problems in one go. So let us make a graph first. As you can see, we have been given edges. As you see in the problem, we have been given the edges. So we will have to make a graph first. So let's make a graph now. Name it as, let me name it as graph only and make a adjacency list of out of the given edges. So now for int I equals to m I plus plus, I int I equals to 0, I less than m I plus plus. Sorry for my confusion. Yeah. Now graph of adji 0 dot push back adji 1. Okay. Now it is an undirected graph, so the this will be pushed from that one node will be pushed into 0 also. Okay, this will make me a undirected graph. Okay, now check for connected components. For that, I will require a visited array vector int viz. Okay, now set it to 0 also and comma 0. Now for int I going from 0 going up till what do you say n number of vertices I plus plus. If my node is not visited, in that case, let me make a variable to store the number of components. So int components equals to 0. Okay. In that case, components will be incremented and BFS. Let's say BFS, we are using traversal as BFS of the same. And we will have to send our graph here, graph there, a visited array there, and my node there, from which I have to start the BFS parameter. After this, if my components is actually greater than equals to greater than 1, not equals to, in that case return 0 as in false. Okay, after that check for cycle. Okay, now when I will be checking for cycle, I am sure that I have only one component, that is a connected component. So now if cycle in graph, if cycle is a function, sorry, if cycle is present in my graph and it has n nodes, okay, in that case return 0, else return 1. Okay, now I will have to code first the BFS traversal for the connected components one. So void BFS. So my graph will be named as graph only. It is a array of vectors and it will also take in vector int and viz and my int start. Okay. Now as in as we use it BFS, we have to make a queue of int of this and queue dot push start into it, mark it as visited in the visited array. Then my BFS traversal starts, that is while q dot empty. My node is actually q dot front and then q dot pop. Okay. Now for auto it in graph of node, if it is already visited, or if it is not visited, then q dot push that node into the graph, so that it into the graph and mark it as visited. Okay, this is my whole BFS. I hope you are familiar with the BFS traversal. It is fairly easy, fairly simple. Return and only return because it is void type. Now, bool for cycle. What was it taking? It was taking my graph and my number of vertices. Graph and my number of vertices, name it as n. Okay, now here also I will have to create a vector to store the visited and unvisited arrays and comma 0. Now my queue will be slightly modified here. It will contain a pair instead of only int. Queue of pair of int comma int, name it as queue, and queue dot push. So I know that there is only one component, then only I'm able to reach this function. So I'm not coding down for the whole components. I'm using 0 as my starting node and minus 1 as parent. Now same the above technique, while queue dot empty, what do you have to do? Now my node is actually queue dot front dot first and my parent is actually q dot front dot second. Okay. Now also have to q dot pop here. Q dot pop. Okay. Now for auto it in graph of that node, that is a dependency list of that node. What do we have to do? If it is already visited, there can be two cases. If my parent is equals to it, in that case continue, no problem. Else return false. Because if it is not my parent, then it is another one which is already visited, and it is only possible when there is a cycle present. Okay. Else, if it is not visited, and then q dot push that it with node as it parents, and then with of it equals to 1. Okay. If the whole loop runs fine, then return uh, return false here, that there is no cycle present, and true here that there is cycle present. Okay. Now, if my cycle is present, then true, and then okay. So let's see if it works fine. Compile and run. Running fine for compile and run. Till then, please subscribe to my channel. And as you can see, we have passed the test cases. And so keep coding, stay safe, stay healthy, and that's all for today. And this is a sincere request to please subscribe to my channel. As I'm seeing that a lot of you have not subscribed to my channel. Please, it will take just a moment out of your precious time, and it will give me a lot of motivation. So if you're liking my content, please drop a like. Please engage with me in the comment section. Please join my Discord server, and don't forget to subscribe. Okay, see you in the next video tomorrow.